Now here's one more set of examples to try to demonstrate that there's really two things at work here. There's the scheduling and then there's the calculation. So let me go ahead and copy this back to our original. And what I'd like to do is show you now that there's no necessarily, it's not necessary to have this interval that you see here and this interval that you see here be the same interval. Now they typically are. It would be very unusual to come up with an interval that's any different. But for example, if I were interested in just figuring out, oh, let's say I'm on shift B and shift B was doing nothing but graveyard shifts for the last week or so, I might only be interested in the maximum from the 8-hour period, not the 1-day period, but the 8-hour period ending at 7 a.m. So I could go in here and change this. Instead of 1 day, let's just change this to 8 hours. Now you'll notice when I do this, the values are going to change. When I press return, the values will change because the calculation is different. But look at the timestamps. They stay exactly the same. Now this is a real subtlety. Now what we've done here is we've presented what could be a real stumbling block for anybody reading this report if they're not real focused on detail. Because now it's showing us these timestamps as though these are 1-day intervals, but they're not 1-day intervals. They're not 1-day, they are 1-day intervals, but the calculation is different than the timing of the interval of the calculation. The calculation is an 8-hour calculation. So this is simply saying what is the 8-hour maximum for that 8-hour, or the maximum for the 8-hour period ending at 7 a.m. Now this is giving me nothing but the graveyard shift for the last 7 days. And as you can see, there is no strong relationship here, and it can get very complicated, but that's because it's powerful. It's a very powerful a combination of things here. So of course whenever you hear powerful around computers, it usually means it's very difficult, and it is. There's no denying it. You could easily get yourself kind of confused with the relationship between the timing of the calculation and the calculation itself. What is it you're actually doing as a calculation? Now let me give you one more example. So here, this is a series of night shifts, all ending at 7 a.m. If I were, let's say I was interested in the actual maximums for each shift during that period of time, I can change this now to 8 hours. Now when I change this to 8 hours, a couple of things happens. First of all, the results are more than what we can fit in this array. So as I've demonstrated before, we can go in here, do a right mouse click, and choose resize so that we can see all the rest of our data. The other thing that's happening here is now we are doing the calculation. We're scheduling the calculation here. That's what this does. This provides the scheduling information. We're scheduling this calculation to take place 3 times a day. So 3 times a day, ending this morning at 7 a.m., we are doing that 8-hour calculation. This is telling me the 8-hour period ending 7 a.m. today, that was the max. For the one that ended 11 p.m. yesterday, that was the max, etc. But you got to make sure you're careful how you formulate your formula and any time intervals explained expressed in the formula versus the time intervals expressed in this sampling method here. So that's just something to keep in mind. Again, just to give you an example, if I were to change this now, this is a really bizarre calculation, but how about this? This is now switching over to 1 day. Well, what in the world would that be? Well, this is now showing us the 1-day maximum ending at 7 a.m. So this was the maximum in the previous 24 hours. This was the maximum the previous 24 hours to that. So you see, it's not always real straightforward. Or I shouldn't say that. It's not always obvious unless you inspect these two elements exactly what you're looking at. It is straightforward. It's just it may not be obvious to your users. So yeah, that's something that I think that would be more typical that you'd see in a report. So this is the night shift, the end of the night shift. This is the day shift. This is the swing shift, etc. Okay, at the risk of belaboring the obvious, let me show you one more variation. Let's go back and look at that hour function. Remember, hour shows me the hour in the day. If I were to do that, look at the results now. Hour is simply telling me the hour of the time at which the calculation was triggered. So asterisk is the current time with regard to the calculation scheduling. As you can see, 7:30 3:11, 7:3:11. That's what we're doing. We're basically telling this the timing that will be used for that calculation. You can also use an expression calculation with this time data function, and that would allow you to do calculations at unevenly spaced intervals. To demonstrate this, I just brought in a tag here that's getting its data at all uneven intervals. Maybe, like, for example, lab data might do this. It's an hour and a half apart, and then only 30 minutes, and then another hour, etc. So, at all uneven intervals, here we go from a 5-hour gap here to a 1-hour gap. At uneven intervals, you still may want to do a calculation. Like, for example, in this case, I don't know, maybe I've got some kind of a compensated flow or something, some calculation I'd like to do. So I will go ahead and do a retrieval of this calculation right here. It's a very simple calculation, but it's going to be based on these time intervals here. So I'll simply choose time data. The tag name, we're going to skip in this case in favor of a pi expression. So there's my expression. My timestamps are going to be this array of timestamps here. And so here are our results. These values here, these calculated values here, are all based on these timestamps right here. And of course, if I make a change here, take this and multiply the result by 3, we see the results over here. So now it's a calculation. If we edit this, you can see it's based on that calculation using these timestamps. Now lastly, do you remember this calculated data function? With calculated data, we had some predefined calculations like totals and averages. Well, we can actually use a pi expression with this function. Let me demonstrate when this might be useful. Yeah, it's kind of tough to describe when this might be useful because, well, it's rare that you want to do some statistics or calculations on a calculation itself. But let me give you an example. Let's say I have a calculation of these, very simple calculation, these two values, process values, sinusoid and CDT158 together. They're some kind of a performance metric that I like to use in operations. And what I'd like to do is find out what was the 8-hour average for the two of them together, adding them up together and finding out what the average was. To do that, I can go into calculated data. I'll use instead of a pi tag, we're going to do an expression, and this is going to be the expression. So for my start and end time, we use that interval there, or that start and end interval. And for the calculation, I can choose average. And what this is going to do is produce an average of that calculation. We'll show the, let's go with the start time, or let's go with the end time that we're going to show. I'll go ahead and click on OK. And what we're showing here is that these values right here, this 215, that's the calculation as of this 8-hour period ending on the 11th of July at 3 p.m. This is the average as of the 8-hour period ending 11 p.m. So it's the result of this calculation. And just to demonstrate that, let me make this easy. I'll just say 2 plus 2. Well, obviously, no matter what time of the day it is, that's going to be the result of that calculation and the average of that calculation. But in this case, what we're saying is this calculation has, during that period, this average as its result. Now compare that to these two calculations here. With these two calculations here, what I've done is I've looked at those same variables individually, just using let me bring this up on our screen here. Yeah, using the pi expression or sampled data. So for sampled data, we've used an expression to calculate the 8-hour average for the tag sinusoid, and we did the same thing. Yeah, here we go. We've done the same thing for the tag CDT158. And what that produces for us is it produces an 8-hour average ending at 3 p.m. The 8-hour average for that tag, sinusoid, is 39. For CDT158, it's 176. You add the two together, it's 215, which, no surprise here, it's the same as the average of the calculation adding the two together. So it is kind of an obscurity, but if there is some calculation whose results you would like to either average or totalize, you can use this. It's this function right here, the calculated data function. And as you can see, it supports an expression. Now at this point, and especially with this last example right here, this last calculation right here, it may kind of make people wonder, what's the point of doing an expression calculation like this, tag average, versus just using calculated data for the same thing? Couldn't we do calculated data to bring in, the pi tag name between that start, end time, and interval, and just do an average? What would the difference be between using this calculated data option and doing it using this option right here? Well, the main difference is if you use an expression syntax, an expression calculation, I should say, you have the option to, as I demonstrated earlier, to make changes between the calculated time span and the actual triggered time span of the calculation. Now, I'll give you an example. This illustration here in your book shows two calculations, one using the pi calculated data method and one using pi expression. Now with calculated data, if I were to say, give me a 1 day maximum from asterisk minus 7 days to the current time, then it's simply going to slice through the data 1 day at a time and give me a maximum, 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 etc. Okay? And that's if you're using just the traditional calculated data option with asterisk minus 7 days and the interval of 1 day. If you, on the other hand, were to choose this tag max option, by choosing tag max, you don't have to be limited to making the calculation exactly the same period of time as the triggering. So we could do an 8-hour calculation, as you see here, just an 8-hour calculation that has its end time at exact 1 day intervals. Okay. As I demonstrated over and over again at the beginning of this video, that there is no requirement that this timing mechanism, the timing mechanism that you're using right here, that timing mechanism doesn't have to be the same time interval as the interval in the calculation. And that's about the biggest difference between doing this using pi expression, using that expression syntax, versus just using the calculated data function.